I just want to make a brief introduction and an overview of standardization rather than talking about a particular topic. One of the main messages that I want to give is that standards create user communities. One of the ways that they do this, I think, is to provide a common understanding. And this is something I quite like in the STEP effort, that there is very formal definition of what things mean. And I think that's important for building up common understanding. But one of the things which is perhaps not appreciated, that as well as geographically distinct locations and trying to pass data between companies, the standards also work in time. You've got a much better chance of archiving data and being able to reuse it if you use a standard rather than if you use any proprietary format. I was asked to talk about ISO work, and if you look at the ISO committees, there are a lot of them. There are some websites, you can find them easily from this www.iso.org. I've got a list of them. And a few more. Okay, you get the idea. So trying to isolate what we need for any particular project is very difficult. So I'm not going to try. I'm afraid this has to be done by the project people. They have to look at what they need and where the information is. One thing, another point to make, which I'll take the committee, or the technical committee where I'm active, you have a number of things called subcommittees. And you have subcommittee 1, where I work mainly. And this works on physical device control. We also have another subcommittee which is working on robots. You have SC4, which is what Martin just described, working on industrial data, and then you have SC5, which is working on interoperability and so on. But what I wanted to say with this as well is that if you look at SC1, where we work, it's very small. SC4 has been huge. It varies a little bit because I think several of the programs are maturing or have matured, but I haven't been able to attend very many meetings recently. But there is a difference in size and in structure of the different subcommittees. So you can get a lot of variation. One of the nice things, though, about work in SC1 is it's produced this thing called STEP-NC, and for me, that's an enabling technology. On top of that, you can build a lot of advanced research work. We need it to get round what's really a limitation in the way that things are built up. You can do adaptive control. You can change the behavior of the machine tool according to the machine tool description and whether it's heavier in one axis than another. You can do energy estimation, which helps you with machine tool selection to make your manufacturing more efficient. You can change things, so you can change tools, change machines, do last-minute selection with this kind of thing. So there are a lot of scope for this. It goes on, but I won't go into more details here. If you look at the classical production sequence, you have design, there's analysis, and after that you've got various things: process planning, manufacturing information, and manufacture. And what you have, I'm sure you're all aware of these barriers, the real or potential barriers between these. And having a good standard is helping to eliminate these barriers here. We've still got problems here, and tolerances was one of the things which has been mentioned. Do we have tolerances? Do we need something better than tolerances, a functional description which can be used to derive manufacturing tolerances later from that? And that's a research question. So we haven't got rid of all the barriers, but we're breaking them down, at least with Step NC in this area. Step NC is this. Heard about it. This is the G codes, which Martin just says he wants to remove in the next 5 years, and I say hooray. The change with Step NC is you're getting a high level description. The machine tools now are much more advanced. We've heard about that, having a real PC on this, rather than when the G codes were first defined, you had a very limited aspects of capabilities on the machine. You can do a lot more, you can do a lot more on the shop floor, and that gives you more flexibility. You can also pass back the information to your research environment or to your company environment and make your tools more intelligent. They can learn. I'm not really want to go into the artificial intelligence thing, but just algorithmically you can improve things by setting up options. It's not real artificial intelligence, but you can make things more intelligent. The benefits are summarized here. I stole these from an old presentation. You've got your CAD/CAM data coming down directly. You can do modification, which has been shown in 1 or 2 sites like ECN with Professor Ascoe. There's splines directly handling improved surface quality rather than having the approximation done away from the machine tool and not knowing what the machine tool capabilities are. The European consortium who were involved actually represents quite a wide range of views of the problem area. So you've got the control manufacturers, and Siemens were very, very active. There was a very good person called Peter Muller who was involved and led the project. There's machine tool manufacturers, there are CAM manufacturers, organizations, and end users, research. So it was quite an advanced and widespread effort. Now, this is where somebody should phone doctors and get me taken away, because my presentation is a little schizophrenic. From the point of view of a sort of system or standard developer, I have to love them, but from the point of view of the user, I hate them. So standards are not magic solutions, and they need work. They need work to develop, they need work to implement. And the standards may not be right, and this is difficult to handle. So the light relief is this, the very old joke about what's a camel. The answer is a horse designed by a committee. The punchline is that standards for communication are also designed by committees. And this is something which I think puts people off a little, that they think, oh well, it can be done more efficiently or something else. But if you do something in ad hoc needs, then you're limiting yourself. If you work through standards, even if you just then convert them locally, you have got these advantages of common understanding with other people, and you're passing on information for the future. The committee work looks a little bit like this. These are things I use in my course, that you have a lot of different personalities. You won't get around that, and everyone knows this, that you get people who are very strong and very good, you get people who are out to promote their own interests, you get people who are just very stubborn or not do very much or work away slowly. So you've got a whole variety of people. Most people naturally pull in different directions, and they need to be steered and managed, and this is one of the problems with standardization. For companies, company participation, we've seen in the past, and this isn't directed at ISO, but we have had standards in the past where companies try and get involved to promote their own interests, and try and get the standard as close to what they want as possible. Oops, sorry, pressed the wrong button. This happened with a standard called IGIS, which had a huge number of types and got very difficult to read and very unmanageable. But the lesson was learned before STEP came along, and STEP has done a great deal to get around this kind of problem. There's another problem, again, with standards, and again it's been known for many years that standards can be out of date by the time they're finished. And ISO has attacked this problem by putting time limits on and try and get standards out much more quickly to avoid this problem. We had the example of GKS, which was a graphic standard which arrived as a two-dimensional standard when 3D graphics was already on the market. IGIS was there's another example. They started as defining drawings. They then moved into solid modeling and went for another technology which has more or less disappeared, called CSG, or is much less widely used than before. And if you look at the format, it's 80 columns wide. For example, I used to ask my students if they knew why it was 80 columns wide, and then triumphantly told them that it was because punch cards were 80 columns wide, and IGIS was originally designed to be stored on punch cards. And then the students started asking me, what's a punch card? And I realized how much of a dinosaur I am. One thing I would like to say, though, is I would like to try and move standards into the research area, because standardization is like trying to hit a moving target. So if you aim directly at your target, then it's moved on by the time the standard comes out. So if you can get research into the standards to make them not open-ended but open-fronted, so that they anticipate the developments, then your standards will be more relevant. So we normally in real life as well, we've got things like this that you have very tortuous routes, and standards may be able to produce standards which follow this closely, but research can produce things which are slightly better by trying to remove the wrinkles and get the direction right, rather than trying to imitate the nature too closely. Just like to finish and let people get on with this. So sort of semi-dream, I would like to see a publicly funded European Engineering Institute. We've got lots of things which are getting close to this. One of the things I'm worried about is the kind of knowledge continuity and sustainability, especially in Europe. But if I take this as a kind of scenario, for SMEs, the standards could help by providing education and a way of helping SMEs find the information that exists in the areas they're interested in. We're getting presentations about education from Dimitris, I think, later on. It would also be nice to let the SMEs see the research in their own environment, so they can plug their problems into research programs and see what's relevant for them. We do need, I think, support for European voice in international standardization. Several people in SC1, I think, are put off by having to pay the fees to the Standardization Institute without getting any particular credit for this from governments. And we're missing out on a stable support for people. It'd be nice as well to have some matchmakers for academic and and commercial world, so we can get more of the real world problems into standards. So we get the real problems that people are concerned with. It would be nice to have more pressure on commercial suppliers. One of the examples I use when teaching is the notion of, say, a screw thread, which is not passed down if you save from the CAD system we use, it's not passed down into a steps file. It exists in STEP. It's been known for a long time, but the CAD companies haven't always implemented the standards in the way they should. And things like benchmarks and standardized understanding of what a CAD system can and doesn't do will help, I think, advance the commercial suppliers and get them moving, which is where we need support for the implementation. And that's it. You can have your coffee, and I'll shut up.